Okay, hello. This is our review for Unit 8, 9, and 10. Here we go. Solving linear inequalities. What does the word linear mean? Linear means you're going to be graphing a line. Inequality means you're going to be shading the desired solution area. Okay? So linear inequalities, you are going to solve just like an equation. Okay? This is where you have x is less than or equal to 10, x is greater than or equal to 10, something like that for your answer. And then you plot your answer on a number line and you shade up or shade down depending on the inequality symbol, okay? An inequality has infinitely many solutions as opposed to a linear equation, which just has one solution. Always write the variable on the left, and when you multiply or divide, why do we say multiply or divide? I feel like we've only ever hammered home division because division is multiplication by a fraction. So when you multiply or divide by a negative number, you flip the sign and always graph your solution on a number line to answer questions. So if they give you an example and it's like, what's the largest integer value that satisfies the following inequality, right? You would get something that looks like this, right? I just made this one up, so I don't know if it's going to have nice numbers or not. We'll find out. Perfect. Has exactly what I want. X is less than or equal to 3 over 2. I want to put this guy on a number line so I know exactly where my region of solutions occurs. What's a little below and a little above 3 over 2? Well, 3 over 2 converts to a decimal of 1.5. Yeah, so let's do 1, 3 over 2, and then 2. At 3 over 2, we have a filled in circle, and then x is less than or equal to. So if we had to answer a question that was like, what's the largest integer value that satisfies this equation? An integer is a positive or negative whole number, so we would say 1. Do you see why graphing your solutions on a number line is going to help you answer questions about the problem in the future? If you just write the inequality, it's kind of difficult to figure out what it's asking you, right? All right. That's for solving linear inequalities. That's when you isolate the variable all on its own, and then you answer a question based on whatever your answer was. Graphing linear inequalities is when you graph the line and you shade. You have to select the proper type of line, dashed or solid, okay? So for example, you could get something that looks like this. Go ahead and draw a picture that's going to let you know, like, okay, I remember these now. So you got like a dashed line, right? And so you shade down. Then you have a solid line. Shade up. And then you put a big S in the region where this inequalities overlap. So right here. Okay. Are these ringing a bell? You remember these now? Okay. So here's what you got to do. Graph the lines like normal. You might or usually have to be in relation mode. You can get the inequality symbols by doing Control equal. All these symbols will pop up and you just type it in the way that you see it. You need to consider the line type, dashed or solid. How do you know which one to pick? A solid line is going to have a solid line underneath. You can remember it like that. A dashed line has no line underneath. Then you need to consider the shading direction. The inequality symbol will also dictate the shading direction. Greater than or equal to, or just plain greater than, you're going to shade above. Less than or equal to, or less than, you're going to shade below. And then number 4, you label, make sure you label both of your inequalities. If there's more than one inequality graphed on the graph and you didn't label, that's a whole point off. Make sure you label them, okay? And then draw your S on the solution region. Bless you. You guys see that pollen that looks like snow that's like gathering on people's lawns?
You mean cottonwood?
What is it? Is it cottonwood? Oh, jeez. What does number 3 say? Consider shading direction. So when you solve a system of linear equations graphically, you're doing all the stuff that you did up top. Let's just talk about the solution set, where it's located, what it means, okay? So the solution set, aka the set of all the answers, is where the shaded regions overlap. It's where your S is. How many solutions will a system of linear inequalities have? Infinitely many. Why? Because you could keep zooming out, and the solution area will keep getting larger and larger and larger, and you can keep doing that forever. And then this is just a reminder. Points on the or a dashed line are not included in the solution set. Okay, so look at this rough example that I drew up here, right? This point right here, is that the solution to the system of inequalities? No. First of all, the solution to a system of inequalities has infinitely many solutions. Those solutions are points that are located anywhere in the region that's labeled with an S. And that point where the two lines cross is not even a point in the solution region because it's on a dashed line. Okay. Great.
So why is a dash line not considered a solution?
Because it's using this type of inequality symbol, right? And you don't include that value in the solution set. So let's say you have x is less than 5. If you graphed this guy on a number line, right? You don't have to copy this down. I'm putting an open circle on 5. Am I including 5 in the solution region? No. So all the points that fall along that line that has this type of inequality symbol are not included in the solution set. It's just like in this case where we don't include the 5. Okay? Great question. Is it because you're being recorded? All right. Writing. Hey, Mr. Krause.
It's like girl boy.
No, they did this all on their own. Like a middle school dance. Love you guys. Okay. So it says now we have to write a system of linear inequalities. What do you do for writing a system of linear inequalities? Well, read the question, right? If they say, write an inequality to model this situation, how many inequalities are you writing? Write an inequality. One. What if it says, write a system of inequalities to model the solution? It's 2, or in some sneaky situations, there could be more depending on how many totals you have. I don't think the Regents is going to ask you for a system of inequalities that has 3, but remember that MYP exam that we took, and there were 3 inequalities on there? There were. Okay. So you want to have the number of totals dictate the number of linear inequalities that you're going to be writing. They usually only have you do 2. Okay. So first you're going to identify the totals and read the question so you know how many inequalities you're doing. You could identify the totals with a little t or a t with a circle around it. That's what I usually do. That's usually just like a fixed amount of money. 20 ducks and chickens all together. Okay. Then you're going to write the equations like a plain old system. You let x equal, let y equal, write your 2 equations, and then you leave a little space where the equal sign should go, because that's where your inequality symbol is going to go. You are going to select the inequality based on the language of the problem. Do you remember doing things like this where it was like at most, at least, no more than, no less than, based on the language of the problem? Okay. What do you do when you encounter a problem like this? Do you guys remember the trick I taught you? You don't need to memorize what at most or at least means or anything like that. You could just figure it out every time by doing this one little trick. What to do with sneaky inequality language? You make a number line with a little above and a little below. Hello! We have an auditor. He's auditing us. He's just making sure everything's above board. With a little above and a little below. And then you consider which inequality symbol you should use, right? So, for example, at least 20. So you have like a number line that looks like this, right? And I'm like, at least 20. What the heck does that mean? What number should go in the middle? What should you put on the left? 19. What should you put on the right? And then you ask yourself the question, right? You're like, okay, at least 20. Can it be 20?
Yes.
Yeah. So I'm going to put a little filled in circle. Oh, sometimes it does that. Can it be 19? No, right? Can it be 21? So you shade up. So your inequality symbol is going to be x is greater than or equal to 20. Okay? So that's your little trick. That way you don't need to memorize no more than, no less than, at most, at least, right? That's like a lot to memorize. Do this trick, you'll get it right every time. Okay. Now, piecewise functions. Piecewise functions look tricky, but you just have to remember how to graph them on the calculator, and then you just reproduce the graph on the page. Okay? So the clue or the indicator that you have a piecewise function is going to be the curly bracket with multiple pieces. What do I mean by multiple pieces? You've got something that looks like this. Yeah. Ooh, whoop. You got 2x minus 5, x plus 1, and then negative 3x plus 1. All right, these are the piece numbers, right? So how many pieces is this graph going to have? 3, right? Hold on, I'm going to move this. Okay, so the number of pieces is dictated by the number of little equations that are right here. And then you have a second part, which is the inequality, and that's going to tell you where the piece starts and stops. So this could be for x is less than negative 2. This could be for between negative 2 and 8. And then this is going to be for when x is greater than 8. Okay, so this is for where the piece starts and stops. And whenever you have a piecewise function and you're trying to reproduce the graph onto your paper, you're going to want to remember what kind of hole that's going to make, an open or a closed circle. So x is less than -2. Is that going to be open or closed? Open. Do not include -2 on that piece. The end point will be at where x is -2, but it'll be an open circle. What about on the second piece? Is -2 included in the second piece? It is, and it's going to be filled in because of the inequality symbol. Is 8 going to be a point on the line? It is, and it's going to be filled in because of the inequality symbol. And then what about x is greater than 8? He's going to be an open circle, okay? So go through, and this will tell you what the endpoints of each one of the pieces should look like. So that's going to be step 1, figure out the endpoints. That's not how you spell figure. Figure out the endpoints. Graph in your calculator. And the way that you graph it in your calculator is you do the lobster and then select the appropriate number of pieces with a spot for the inequality. In this example, I guess you would have 3. So we'll just make that our example. Okay. And then to get grid lines, because sometimes you don't know where the endpoints are, right? If you do graph trace, it skips an open circle. So you want to use grid lines to help you see where a piece should start or end. You do menu 2, 6, 3, 4 grid lines. Okay. All right. Rational versus irrational. These are the definitions you must write on the Regents exam. They will not give you full credit for the answer if you do not write these. So what should you do with these? Just memorize them. Put them in your brain. A rational number can be written as the ratio of 2 integers. An irrational number is a decimal that goes on forever and doesn't repeat. An example of a rational could be any number, 4.25. Can I write him as a fraction? Test it on your calculator, right? Of course, my calculator is not open right now. Oh, I'm so excited to waste everyone's time. I don't need Father's Day gift ideas. I don't need that. I do need my calculator, which is... There we go. Okay. If you're wondering if something can be written as a rational number, you just type in the decimal. Here, I'll tell you how to do it. Go to a calculator page, type in 4.25, and then you're going to go to... I'm waiting for this thing to load up. You're going to go to menu. Here's your calculator. You get a class calculator to follow along. Go to menu, 2 for number, and then 2 for approximate to a fraction. So then your evidence that it's a rational number is going to be the improper fraction that you get. You write, yes, it is a rational number, right? That's 1 point classifying whether it's rational or irrational. And then your second point is your evidence, the definition of a rational number and why it's rational. You write down the improper fraction. What is it? Okay, great. So an irrational number, right? First, you get that point. You classify it as rational or irrational. Then you explain why using your example from your calculator and your definition, okay? So the square root of 2. How do we test and make sure that something is irrational? Square root of 2. Type it in your calculator. And then what's the trick? You hit enter. It looks like that decimal ends, right? You got to hit up, highlight it, hit enter again. Oh, more digits come up. There's no repeating pattern. I know that this guy is irrational because he is a decimal that does not end and does not repeat. Okay? So you would just write that as your evidence. What it looks like on your calculator, you do menu. Yeah, what's up? 2, 2. So you give the number and definition. Did you have a question, honey? Okay. For irrational, you pick up the decimal and see if more digits come up. Okay. All right, arithmetic sequences. You are looking for a term in a long string of numbers. The numbers in the term are going up, and the terms in the sequence are going up or down by the same number each time, adding or subtracting, just like linear. Okay? This is on your reference sheet, so is geometric sequences. So go ahead and put a star reference sheet. Star reference sheet. Arithmetic sequence can be found on your reference sheet. It looks like this. A sub n, that means the specific term that you are looking for in the sequence, can be found by substituting in a sub 1, that's the first term in the sequence, plus d, which is the common difference, times the number in the sequence that you are looking for minus 1. Okay? And then you could put a little star. This is just like a linear function. This is your common difference, just like the slope. This is the number term you're looking for. This is the actual term you're looking for. Like, what is it? The number 20, the number 21. And then this is the first term. Going up or down by plus or minus. Okay, just like a slope. Geometric sequence, a geometric sequence. This is going up or down by a common ratio. That means it's going to be times or divide, but you can't do divide, just write fraction. Why? Because the number, the base of the exponent is called a multiplier. You must be multiplying, you can't divide. In order to simulate division with multiplication, you multiply by a fraction. This is similar to an exponential function. Come on. Why? Oh, I don't care. Whatever. It's fine. Okay, so off of the reference sheet, right? You're going to get a sub n, which is the term you're looking for, actual term. And then you're going to have a sub 1 as the starting value or y-intercept. R is the common ratio or the multiplier. And then this is all raised to the n minus 1. If you ever need to find R, you can do second term over first. Oh, there's too much going on in my calculator. In my computer, he's getting slow. He's getting slow. Look at him, he's slow. Okay. So, R, is this the kind of instance where I would have to redo the video because I'm singing? Okay, converting units. You've got your starting units. You're going to multiply by a series of ratio conversions in order to cancel those units, and you are going to arrive at your desired units, okay? That is dimensional analysis in a nutshell. So let's write that down. We've got starting units. That's when they give you miles per hour. A panda can eat 50 bamboo shoots per day, something like that.
Eat more than that.
Are you writing this as fast as you can? Or are you crinkling garbage? Series of ratio conversions in order to cancel units. Units will cancel when they're in opposite parts of the fraction. And you will arrive at your desired units. All of the ratio conversions that you will need for this test, with the exception of like 24 hours in a day or 12 inches in a foot, can be found on your conversion sheet. At the top of your reference sheet. So you can put RS. All right, we're cruising. But still not fast enough. Okay, we gotta go. All right, rewriting formulas or solving for a variable in terms of others. You have the solve for all by itself. If they say solve for X, solve for K, solve for P, in terms of is all the other variables on the right. Okay? That's it. You just got to use your knowledge of inverse operations to isolate the desired variable, and then you put everything else on the other side. Okay? Adding or subtracting radicals. Are they like terms? If they're not like terms, can you rewrite to get things to cancel? All right, let's skip ahead to number 1 on review questions of the day. Right here. It says, what is the sum of 3x radical 7 plus 2x radical 7? Why am I showing you this after I just explained it to you? Let's practice with the rules, right? First of all, are these like terms? Do they have the same radical? Do they have the same coefficient type? Yes. So what you're going to do is add together the coefficients. 3x plus 2x is 5x, and then keep the radical. Your answer is A. Pretty easy?
Yeah.
Sounds good. Let's go back.
That was it.
Multiplying or dividing radicals. What do we got to do for that? Ask yourselves,
Multiply or divide.
are they like terms? Can you rewrite things to cancel? For example, ooh, get out of there. For example, I have the square root of 48 divided by 2 times the square root of 3. Are radical 48 and radical 3 like terms? Can I just cancel them? No, right? Let's put 48 into simplest radical form and then see if anything cancels. What factor of 48 do you think you should try to look for here?
5.
A radical 3, because then they'll just cancel one on top of the other, right? So divide 48 by 3. What do you get? What's 48 divided by 3? 16. So I'll rewrite this as the square root of 16 times the square root of 3 over 2 times the square root of 3. This is me rewriting things so they cancel. What happens? These cancel? Yes. What's the square root of 16? 4 divided by 2. My answer is 2. How nice. Rationalizing radicals. When you have a square root in the denominator, you must rationalize. When you have a square root in the denominator, you must rationalize. Okay? For example, you have, actually, let's just do the example problem on the review questions. Scroll down. How do we rationalize? Question number 2, it says, rationalize 3 over 2 times the square root of 6. What's the square root in the denominator? What is it? 6, right? So I'm going to multiply both the numerator and the denominator by the square root of 6 over the square root of 6. When I multiply fractions, I do numerator times numerator, so 3 times the square root of 6 over denominator times denominator. I would get 2 radical 6 times radical 6. What do you know about radical 6 times radical 6? What does he turn into? 6, right? So I'm going to have 3 radical 6 over 2 times 6. This becomes 3 radical 6 over 12. If you want to see if that guy reduces or not, you can go to your calculator. I mean, you could just see that like they're both divisible by 3, so I can cancel. But you could just go to your calculator, type in only the coefficients, not the square root symbol, because then you're going to get an irrational number. Type in just the coefficients, 3 over 12, and your calculator will reduce it for you. Radical 4. 1 over 4. So you'll get radical 6 over 4. These reduce to 1 over 4. And you have gotten rid of the square root in the denominator. You rationalized. Good job. Let's try number 3 because it goes in line with the stuff that we were just talking about, solving for a specific variable, okay? Tyler, are you alive? You don't look very alive. Okay, so what are we going to try to do here? It says the formula for the volume of a cone is volume equals 1/3 pi r squared times h. The radius, or r, of the cone may be expressed as. So it's asking us to solve for who? Solve for r. Oh, come on. I'm crunched for time here. No. I got too much going on. The computer does not like this. It is like, lady, you need to calm down. All right. Solve for, it's saying you do less, please. Okay, we have solve for r. So we're going to take this guy and we're going to get r all by itself. What is the operation in between 1/3 pi, r squared, and height? What is the operation? Multiplication. So what is the inverse operation of multiplication? So I could divide both sides by all the coefficients of r to get r squared all by itself. Then I just square root both sides. Okay? So what would I need to divide both sides by in order to get r squared by itself? I'm going to divide by 1/3 pi h. Okay? These all cancel. And I'm left with v over 1/3 pi h equals r squared. I'm going to square root both sides, square root both sides. Okay, it looks like they don't have any answer choices with a 1/3 in the denominator, right? So let's go ahead and type in 1 divided by 1/3 in our calculator and see what we get. Oh, it's a 3. So 1 divided by 1/3 gives me a coefficient of 3 with the v. And then I have pi h in the denominator. Your answer choice is choice 1. Okay. And while we're already over here, let's do number 4, right? It says, we're already here. Given 2x plus ax minus 7 is greater than negative 12, determine the largest integer value of a when x equals negative 1. So what are you trying to do here? You're going to try to solve for a, and then, hold on, when x is negative 1. Oh, let's put that x in first, and then we'll try to solve for a. That sounds good. Otherwise, we have too many variables. So let's take that x equals -1, plug him in everywhere we see an x, and then solve for a. 2 times -1 plus a times -1 minus 7 is greater than -12. -2 minus a minus 7 is greater than -12. Let's combine our like terms. Let's add 9. I'm going to divide both sides by a negative. That means I'm going to do what with the inequality symbol? Flip it. A is less than 3. I'm making a judgment call on the nature of the solutions. It says, what is the largest integer value of A? So let's go ahead and put our number line, right? We're going to do a little above. We're going to do a little below, a little above. A cannot be 3. I'm going to put an open circle, but it does have to be less than 3. What's the first integer I hit in my solution area? 2. Okay. All right. And we could do 5 while we're at it. Hello. The graph of an inequality, what? Of shown below. The graph. Oh, that's not correct. Whatever. I made this up. That's fine. You know what I mean. Write the inequality represented by the graph. Okay, so we know that a line can be written as y equals mx plus b. You what? Right? Hello? Oh, there we go. Okay, so let's identify the y-intercept of this line. What is it? Great. What's the slope? 2/1. And then what's the inequality symbol? Are we shading up or shading down? We're shading up, so we are greater than. And then what kind of line is that? Dashed or solid? So I'm going to put greater than or equal to. On the same set of axes, graph the inequality right there. Oh gosh, I don't know what that one looks like. Let's put it into our calculator. I'm not even kidding. I think my computer is going to shut down if I try this, but here we go. All right, it's not happy with me. So we're going to go to the graphs. Let's delete our equal sign, go to relation mode. We are graphing x plus 2y is less than 4. Okay. So what is the points of this guy? Let's do menu 5, 3. Menu 5, 1. Let's trace along. Okay, let's take nice numbers only. -4, 4. Put it on there. -4, 4. Okay. Scooch. -2, 3. Scooch. Ooh, y-intercept is 0, 2. Hold on, did I not count right? I didn't count right, did I? Oh, this is good. This is great. I can't count. Okay, so let's go back up. What was it? -2, 3. 1, 2, 3. There we go. And then I've got -4, 4. 2, 3, 4. 1, 2, 3, 4. Wow, that's fun. Counting is hard. Okay, so we go to 0, 2, and then we're going to go down to 2, 1. Counting is so hard. Just kidding. Okay, then we got 4, 0. 1, 2, 3, 4, 0. Okay, this looks good. So then we got less than what? I got an A in every math class I ever took in college except for linear algebra. I got a B plus. Still stings. Still stings. I don't teach linear algebra. That's like matrices. You guys don't learn that till college. All right, so we got x plus 2y is less than 4. What kind of a line are we using? Dashed. And then are we shading up or down? Look at your picture. Down. And then where is our region of solutions? S, right there. All right, cool. We did that. The two inequalities graphed on the set of axes form a system. Oscar thinks that the point 2, 1 is in the solution set for this system of inequalities. Ooh, let's see. 2, 1, where is it? 2, 1.
Oh, it's not there.
What do you think? Very good, Isaac. It is on a dashed line. So we would say no. No, not a solution on a dashed line. Okay, so let's see. Look at how hard this thing is struggling. It's like at capacity. It is at capacity.
Why is it like clearing your storage every once in a while?
I don't even know what you're talking about.
You do browsing history.
No. I want to remember everything. I want to remember this moment.
You should probably do it.
Then why don't you take a video camera and record every class you do?
Because that's wild. All right, let's go back to one var stats. We're getting there. We're getting there. Ooh. Okay, one var stats. You calculate one var stats when the question asks you for the mean, median, range, Q1, Q3, IQR, box plots, any of this stuff. Oh, standard deviation. You use one var stats, okay? You type in X, all your data in one column. You hit Control Doc on a calculator page. You do menu 6, 1, 1. Number of lists is always 1. X bar is the mean. IQR is on your reference sheet. Outliers are on your reference sheet. Okay. 2 var stats are for a frequency list when you have X frequency. That's when you calculate the one variable statistics for 2 variables at the same time. Okay. Your X1 list is X, and your frequency list is frequency. Okay. All right. I really want to go over linear regression before you guys leave. Okay. So let's do linear regression. Go to number 9. Number 9. And by 9, I mean 8. Okay. It says at Mountain Lakes High School, the mathematics and physics scores of 9 students were compared as shown in the table below. You have 2 variables. Label the first one X. Label the second one Y. How do I know I'm calculating linear regression? Because in the following line it says generate the linear regression equation. Of course, my computer is frozen. Okay. Generate the linear equation that models the data above. Round all values to the nearest hundredth. All right, we gotta stop the video.